Hello everybody, this is Andreas from the ATPL preparation app Fasttrack ATPL. You can find our application in the App Store as well as in the Play Store. Today I'm going to talk about the topic general navigation, especially about examples from pressure altitude and true altitude calculations. So I already opened our application, and on the left hand side you can see the subcategories. I simply select altimetry. There are 36 available questions. I select all of them. Nevertheless, I will only talk about 2 today, and then I simply start the training. So the first question is related to airport pressure altitude, and there are 2 values given. First of all, the airport elevation is 1000 feet and the QNH is 988 hectopascal. There are 4 results, and of course only one of them is correct. A nice feature is the Show Solution button. This provides you with a detailed step-by-step explanation of the solution and will help you to find the correct answer. So I simply click on it, and you can see already that another window opened on the right hand side. I just make it a little bit bigger, and the values are given. You can see again at the very top, and below it there is already a very important and nice overview, let's say conversion table for true altitude, QNH altitude and pressure altitude, and this will help you to calculate each one of them. Between the true altitude and QNH altitude, you have to apply a temperature correction, and between the QNH altitude and pressure altitude, you have to apply a pressure correction. The question today is about pressure altitude, so we will go in detail to it a little bit later. Before that, I will also highlight the short explanations of the different terms you can find here. This is also very important, and you will need these terms and explanations throughout your general navigation preparation. So you can find explanation of true altitude, QNH altitude, pressure altitude, true height, elevation, QNH, QFE and QFF. So also please keep these explanations and terms in mind. So let's go directly to the calculation itself, and as you might know already, that 1 hectopascal either equals 27 feet or 30 feet. For this example, we assume that 1 hectopascal equals 30 feet in altitude difference. So when you look again at the conversion table, the question today is, or in this example is, what is the pressure altitude, and we have to apply a pressure correction on the QNH altitude, because the QNH is already given with 988 hectopascal, as you can see at the very top. So in order to calculate the pressure altitude, we have to determine the deviation from the standard pressure of 1013 hectopascals. We simply assume standard ISO is 1013 hectopascal. Then we subtract our QNH altitude, which is given with 988 hectopascal. This equals 25 hectopascal. And now we have to convert this pressure difference into a difference in altitude. And as mentioned before, we assume 30 feet per hectopascal. And the calculation would be then 25 times 30, and we get a result of 750 feet. Then finally, we add the difference in altitude to the airport elevation to obtain the pressure altitude. Airport elevation is 1000 feet, and then we add 750 feet. This gives us the final result of 1750 feet for the pressure altitude. So let's see if this is also correct. Yes. So then we continue with the next question. As you can see, this might be a little bit more complicated. There are more values also given. Aircraft at flight level 150 over at an airport. Elevation of the airport is 720 feet. The QNH is 1003 hectopascal, and the outside air temperature at flight level 150 is -5 degrees centigrade. The question is, what is the true altitude of the aircraft? Again, we can see 4 results, and again, of course, only one result is correct. We provide you again, of course, with a solution. Let's tap on it. Window opens again on the right hand side. Let's zoom in. Again, the top you see the given values. Most important, also our conversion table as mentioned before. This time we have to apply the temperature correction with the factor 0.004, and also again the pressure correction. Below that conversion table you find again these important explanations of the terms. And now what is, from my perspective, a nice feature is this little picture which tries to give you a nice overview about the situation. You can see the aircraft symbol at flight level 150, the MSL with the pressure, the given pressure of 1003 hectopascal. You can see, of course, the airport with an elevation of 720 feet, also a layer of air, and all the details which are relevant for us to solve this problem. In this case, we assume that 1 hectopascal in pressure difference equals 27 feet in altitude difference, just to get a very accurate result. And then we just go into the calculation, and again the first step is to calculate the pressure correction to determine our QNH altitude. The standard is 1013 hectopascal, EASA standard, and our QNH is 1003 hectopascal. So we simply just subtract 1003 from 1013 hectopascal, and this simply equals 10 hectopascal in difference. The next step is to convert this pressure difference into a difference in altitude, and as mentioned before, we assume 27 feet per hectopascal. So we just calculate 10 times 27, and this gives us a result of 270 feet in difference in altitude. In the next step, we have to subtract 270 feet from our pressure altitude, because the actual QNH is smaller than the standard pressure of 1013 hectopascal, or to be very accurate, 1013.25 hectopascal. The reason for subtraction is that the QNH of 1003 hectopascal makes our altimeter indicate a higher altitude than the real altitude when referenced to 1013 hectopascal. So In this case, the calculation or the next calculation is QNH altitude would be 15,000 feet. Our aircraft is at flight level 150, and minus the 270 feet. This gives us the QNH altitude of 14,730 feet. Here's also a hint or note. If you don't know if you have to add or subtract from 1013 hectopascal. Here it says a quick and easy way to determine whether you have to add or subtract the pressure difference for calculating the true altitude is by always subtracting 1013 hectopascal from the given pressure value. If the result is positive, you have to add the resulting difference in altitude, and if it is negative, you have to subtract it. Consequently, we could also calculate the pressure correction and QNH altitude as follows: 1003 hectopascal minus 1013 hectopascal equals minus 10 hectopascal. So you know that you have to subtract it. This means the QNH altitude is 15,000 minus 10 hectopascal times 27 feet equals 14,730 feet, which is exactly, of course, the same result as above. Then the next step, we have to subtract our airport elevation of 720 feet because we want to know the distance or the diameter of the layer of air between ground and the airplane. So we go to, or we take the result from the QNH altitude, 14,730 feet, minus 720 feet, the airport elevation. This gives us the layer of air, which is 14,010 feet. I'll just show you again the layer of air, how it is displayed or shown in our picture, that you understand this more easily. You can see here the airport and then the aircraft. And we just did, what we did is we try to find out how thick this layer of air is. So, and when we have found out this value, we can apply our temperature correction now. And the temperature correction is calculated as follows. Also here again, take a short look at this conversion table at the top. You can see temperature correction is applied between the true altitude and the QNH altitude. So, and then we can see that once again the temperature correction, the formula is a factor of 0.004 times the actual temperature minus the EASA temperature. And we know that from our given values that the temperature at flight level 150 is minus 5 degrees. What we also know from the EASA parameters, that the temperature at mean sea level is 15 degrees and the reduction in temperature is 2 degrees per 1,000 feet, which means the air gets colder every 1,000 feet by 2 degrees. So the standard temperature at flight level 150 should be minus 15 degrees, but we only have a temperature of minus 5 degrees. So the difference is 10. You can see here the calculation. Temperature correction is the factor 0.004 times 15 minus 5. These are the 10 degrees difference, equals 0.04. So to make it short, we have to add 4% to our calculated vertical distance to this layer of air. And the calculation would be then 14,010 feet. This is what we found out here. Again, 14,010 feet times this factor of, or let's say, the add-on of 4%, which gives us a value of 14,570 feet. Also, a short note here, if the outside air temperature is colder than the EASA temperature, the true altitude is smaller, and vice versa, as cold air is denser and the pressure layers are more, let's say, more closely together. Then finally, as we want to know our true altitude above mean sea level, we have to add our airport elevation of 720 feet to all these corrected values, and this gives us 14,570 feet plus 720 feet equals 15,290 feet. So this is the final result, and let's see if this is correct. Yes. Yeah, that's basically it from my side. I hope that we could, or that I could give you a good insight into these several steps of solving these, from my perspective, quite difficult tasks. And if you find our app, or let's say our way of solving these problems, well done. Please give us a thumb up, and all the best for your ATPL preparations, and have a very